Hello everyone, in this video we will solve some examples about the increasing and decreasing functions and how to use the first derivative to determine the increasing or decreasing intervals. Example number 1, determine the increasing and decreasing intervals of the function f, where f of x equals x power 3 minus 3x plus 2. The first of all, we must determine the domain of the function. So, solution, the domain of the function f is R. The domain equals R, where R is a set of real numbers. Because the function here, it is a polynomial, and the domain of any polynomial is the set of real numbers. So we will determine the increasing or decreasing intervals using the first derivative. So f dash of x equals 3x squared minus 3. The derivative of x power 3 is 3x squared, and the derivative of negative 3x is negative 3. The derivative of 2 equals 0. Okay, so we will delete it. It is 0. Okay, and we must determine the points at which f dash of x equals 0 or undefined. Here, f dash of x. So put f dash of x equals 0. Then 3x squared minus 3 equals 0. By taking 3 as a common factor, we will get 3 multiply x squared minus 1 equals 0. So 3 multiply x minus 1 multiply x plus 1 equals 0. Because we have here the difference of two squares, x squared minus 1, its factorization is x minus 1 multiply x plus 1. So x minus 1 equals 0, or x plus 1 equals 0. It means x equals 1 or x equals negative 1. So we construct a table using a number line here. It is from negative infinity to infinity. Here we have x and f of x, f dash of x. When x equals negative 1, f dash of x equals 0. When x equals 1, also f dash of x equals 0. Okay, now we will investigate the sign. We determine the sign of f dash of x through these three intervals, from negative infinity to negative 1 here. Also, you can write negative infinity to infinity. And we will choose a number lying on this interval, like negative 2. Negative 2. So, f dash of negative 2 equals, where is f dash? Here we have f dash of x equals 3x squared minus 3. So substituting x equals negative 2, we write 3 multiply negative 2 all power 2 minus 3, which equal 3 multiply 4, it's 12. 12 minus 3, it is positive 9. So f dash in this interval, it is positive. And you can say that the function f of x is increasing on this interval like this, and we choose another number belongs to the interval -1 to 1, open interval of course. Don't take -1 or 1 because f dash of x equals 0 at these 2 points. So we will take 0 and we calculate f dash of 0. F dash of 0 equals 3 multiply 0 power 2 minus 3, which equal -3. What is the sign here? It is negative, so we write sign, and the function decreasing on this interval, and we'll take another number like greater than 1, of course, belongs to the interval 1 to infinity. Here we have +2, and we calculate again f dash of 2. F dash of 2 equals 3 multiply 2 power 2 minus 3, which equal +9. +9. So here we have a positive, and we have the function f of x is increasing on this interval. And we can write all of this. F of x is increasing on the 2 intervals from -infinity to -1, and from 1 to +infinity. And the function f of x is decreasing on the interval from -1 to 1. When you draw the function, when you study this curve, drawing the tangent at the interval from -infinity, here from -infinity to -1, in this interval from -infinity to -1 here. When you draw any tangent here, you will find that the tangent makes an acute angle with the positive direction of x-axis here. The angle theta with the positive direction of x-axis here. Theta is acute because, and also the slope of this tangent is positive, and we write it. Here is tan theta is greater than 0 in the interval such that where the function is increasing. Also, dy dx, it is the slope of the tangent also greater than 0. Okay. And here, what about the increasing of the function from -infinity to -1? When I substitute x equals -2 here, f of -2, it is equal 0. F of -2 equals -2 power 3 minus 3 multiply -2 plus 2, and it is equal -8 plus 6 plus 2, which equal 0. Okay, so we have here the point -2 and 0. And by increasing the value of x, and I'll take another point here like -1.5. So I'll find the value of the function f of x when x equals negative 1.5. Negative 1.5. Its point lies between -2 and the -1 equals. Again, I'll substitute in this function equals negative 1.5 power 3 minus 3 multiply negative 1.5 plus 2. And we calculate it. You can use calculator here. We write the function x power 3 minus 3 multiply x plus 2, and we calculate for x equals negative 1.5. The result equals 25/8. 25/8 equals 3 and 1/8 equals 3 and 1/8. So we have the point negative 1.5 and 3 and 1/8. Note here in this interval, when x belongs to the interval from negative infinity to -1, the value of y increasing as the value of x. When x equals -2, y equals 0. When x equals -1.5, here, note that here, when x equals -1.5, y equals 3 and 1/8 here at this point. And this is the meaning of the increasing of the function. The slope of the tangent at any point on this interval is positive, and when x increasing here, when x increasing, y also increasing. And also, if you take any point in this interval from 1 to infinity, what you get? When x increasing, also y increasing. Here, by taking any point, we'll take 2 points to check the decreasing of the function on this interval. Okay, so here you can take, you can substitute x equals -half. What is the value of y? So again, go to calculator and calculate for -0.5. What is the answer here? It is 27/8. 27/8, it is 3 and 3/8. And I'll take another number greater than -half, like half here. Okay. And we'll calculate for half. And so we calculate the value of f of x when x equals 0.5 equals 5/8. Okay, 5/8. So by increasing the value of x from -half to half, what happened to the value of y? We get at the first 3 and 3/8 and 5/8. It is the meaning of decreasing. And when you draw a tangent at any point on this interval, it will make here an obtuse angle greater than 90 in this interval. Okay, so when the function is decreasing, the slope is negative and theta will be obtuse. Okay, let's take another example. Example 2, determine the increasing and decreasing intervals for the function f, where f of x equals x plus 2 sine x, where x is greater than 0 and x is less than 2 pi. Here, this part expressing the domain. So we write the domain of f of x equals this interval, open interval from 0 to 2 pi. Okay, and we will find the first derivative, f dash of x equals 1 plus 2 cosine x. 1 plus 2 cosine x, the derivative of sine x is 2 cosine x. Now putting f dash of x equals 0, then 1 plus 2 cosine 0, cosine x equals 0. It means 2 cosine x equals negative 1. And cosine x equals negative 1 over 2. So when cosine x equals negative half, it means x equals 120 or x equals 240 degrees. Note that cosine x equals negative half, so x lies on the second quadrant, or x lies on third quadrant, because cosine is negative, and you know that you must consider this. All the trigonometric functions on the first quadrant are positive. Here is sine is positive. Here is tan and cosine. So when the angle x lies on the second or third quadrant, here is the first quadrant, second, okay, third, and fourth. So cosine x is negative. We will take both values. Okay, so x equals, to convert it to radian measure, we write 120 multiply pi over 180, which equal 2 over 3 pi. Or x equals 240 multiply pi over 180, which equal 4 over 3 pi. Okay, and both belongs to the domain of f of x. Okay, 2 pi over 3 lies on this interval here, and the 4 over 3 pi also lies on the domain. So we will check the sign of f dash of x about these two values using the number line here. we have f of x equals x plus 2 sine x, and we have f dash of x equals 1 plus 2 cosine x, and we complete the table. Here we have x, f of x, f dash of x. Okay, and we'll take some numbers. Don't forget that the domain, it is from 0 to pi. It is not from infinity, from negative infinity to infinity. It is from 0 to 2 pi here, right? And we have x equals, you can write 120 degrees here, and also you can write 240, and we check the sign of f dash of x about these two values of the angle. Here we have f dash of x equals 0 and f dash of x equals 0. Let us write f dash of x here using calculator. It is 1 plus 2 cosine x. And calculate for x equals 120 degrees, which equal 0, of course. So I'll take another number less than 120 lying on this interval here, like between 0 and 120, like 60, like this. The value equals 2, and this is a positive. So the function is increasing on this interval. And back to calculator, and I'll choose another value to the angle lying between 120 and 240. You can take any number like 200. So calculate for x equals 200 degrees, and the result here is negative. Okay, so the function is decreasing. Take another number lies between 240 and 2 pi, like 270. Cosine 270 equals 0. So we have 1 plus multiply 0, so it is positive here, and the function is increasing. And you can write all of the previous results. F is increasing on the interval from 0 to 120 is 2 pi over 3. And also increasing on the interval from 240, it is 4 over 3 pi to 2 pi. It is open interval, and the function f is decreasing on the interval from 120 to 240, and write it in radian. So it will be 2 pi over 3 and 4 over 3 pi. Okay, it is the summary of the solution, and this is the answer. Example 3. determine the increasing and the decreasing intervals of the function h, where h of x equals to ln x minus x squared. First of all, here solution. What is the domain of this function? To determine the domain of h of x, so you ask yourself, what is the domain of ln x? The domain of ln x is the set of all positive real numbers. And what's the domain of x square? The domain of x square is r. Okay, so the intersection of these two domains of these two sets, here is intersection, equals r positive. Okay, so the domain of h of x is r positive. Okay, now h dash of x equals 2 over x minus 2x. And the h dash of x is undefined when x equals 0. Right? So here x not equals 0. And we will write it h of x, h dash of x here is undefined. When x equals 0, and the number 0 doesn't belong to the domain of f of x, doesn't belong to r positive, right? Okay, so we will not check the sign about it. Now putting h dash of x equals 0, it means 2 over x minus 2x equals 0. Multiplying both sides by x, what we get? 2 minus 2x squared equals 0. By taking 2 as a common factor, we get 1 minus x squared equals 0. So to multiply 1 minus x, multiply 1 plus x equals 0. When 1 here, 1 minus x equals 0. So x equals 1. When 1 plus x equals 0, it means x equals negative 1. X equals negative 1 doesn't belong to r positive, doesn't belong to the domain of h of x. So we will check the sign of the function h dash of x about x equals 1. So we have h of x equals 2 ln x minus x squared, and the h dash of x equals 2 over x minus 2x. And we'll draw the table here. We have x, f of x, f dash of x. We will check about x equals 1 here. F dash of x equals 0. Okay, and we'll check the sign on the domain of f of x. Of course, here we have 0. The function f dash is undefined here. not exist, undefined. Okay, here is f dash of x. Okay, the domain start from the point just after 0. Okay, so we'll check the sign between 0 and 1 for the given for f dash of x. Okay, f dash of x equals 2 over x minus 2x. So I'll write it here. So we will check the sign of f dash of x on this interval between 0 and 1. So I write it 2 over x here minus 2x, and we calculate for x equals 0.5. It is equal positive 3. So the sign here is positive, 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 and the function is increasing on the interval from on this interval from 0 to 1. Okay, and we'll check a number here from 1 to infinity by taking x equals 2. So we calculate for x equals 2. The result here is negative, so the function is decreasing on the interval from 1 to infinity.